Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald Kers, met mij is, even wachten Jan.
Ik ben Jan Stomphorst.
De Jan Stomphorst, hè?
Ja, de Jan Stomphorst, oké.
Hey, weer 2 nieuwe gasten in de podcast.
Nou, dit is wel een hele interessante, vind ik. En ik vind ze allemaal interessant overigens. Maar dit is wel een hele interessante. We gaan echt wel de diepte in.
Ja, want KEDA, dat stond al heel lang op jouw lijstje.
Ja, take it away, man.
Without further ado, I would like to introduce Jorge Turrado.
Yeah?
Zbyněk Roubalík.
Yes.
Almost perfect. Almost perfect. Okay, so I will start with Jorge. Can you please introduce yourself to our listeners?
Yeah, for sure. I'm Jorge. Thanks for inviting us. It's a pleasure to be here. I'm Jorge. I work in Sparks Group as SRE. Just 5 years ago, I was a developer. Now I am an SRE and one of KEDA-maintainers. Just talking about KEDA.
And how did you get started in the IT?
Oh, I am electrician indeed.
Oh, okay.
I swap. I changed my work from robotics electrician into SRE.
Okay,
Yeah,
interesting.
I was developing since young.
Okay.
So,
Hi, my name is Zbyněk. I know it's hard to pronounce and it's Czech name. I'm from Czech Republic, obviously. I'm also a KEDA-maintainer. I'm with the project since the inception, so it is almost, I think, maybe 5 years actually. The project started, it was like a cooperation between Microsoft and Red Hat. I was at Red Hat back then, and we tried the POC around these autoscaling options, and the project went well, so we donated it to CNCF, and now it's CNCF Agility Project, exciting kinda. And so I was in Red Hat for many years, so I've been around open source and Kubernetes and cloud native technologies. A few months ago, we started a company around KEDA called Kedify. So basically, we would like to offer the same capabilities that KEDA provides, but on the enterprise level, let's say. So autoscaling at scale, basically. So this is my actual job at the moment.
So, and if you would describe KEDA to someone who has no idea what it does, would you describe it?
how does it help us?
We have a lot of stories. Like basically, imagine that you have application. The application is doing some stuff, some important computation, and the computation depends on some external events or maybe external metrics or something like that. For example, the application consumes data from RabbitMQ. And, it consumes the data, do the calculation, but the data flow is not constant. So, sometimes there is a lot of data, sometimes there are no data. So it doesn't make sense to have, like, let's say, fixed number of the applications that consumes the data and process the data. But you would like to bring the dynamicity there, elasticity, basically. So you would like to, if there is a lot of data, you would like to extend the number of the applications. If there are no data, you would like to ideally scale to 0. So saving costs, improving throughput. So this is like the technical discussion.
But there is a difference in resources when we talk scalability. People often think about CPU usage and memory usage, but you have another approach.
Yeah, and you have talked too much just for saying we made the autoscaling that simple in Kubernetes.
Yes.
Okay, and we're done.
My pleasure, guys. We can.
It's a wrap. But
Too many words for saying something.
It's probably the CTO thing at the minute.
Well, Jorge, it's your
So-
turn now.
so you fixed autoscaling in Kubernetes.
Kubernetes, the autoscaling in Kubernetes is quite limited
Mhm.
to CPU and memory. If you have something external or not external, but not related with CPU and memory, the autoscale, the HPA don't support it out of the box. You can use adapters or build your own server, but it's not supported out of the box. And it's a problem because, as Zbyněk has said, if you are processing, for instance, the typical message, imagine the typical email sender when you sign up in a website. Microservice doesn't make sense to be running all the time. But in the other hand, when it's running, the CPU usage is not significant, or it doesn't represent the real usage because you are pulling a message and calling to a third party. So the CPU is not used at all. So why are you scaling based on a metric that is not relevant in your flow? Doesn't make sense. And there are users. For instance, there is a study case with Zapier. They pull messages from Rabbit and do the tabs. In that case, the CPU increases only when they are late. They are processing too many messages and they are late. Let's use the critical metric for scaling, not side effect metrics like CPU and memory.
Yeah.
So CPU is always an after effect.
If you have an OCR, because you are processing images for reading code, code, that workload is CPU intensive.
Yeah.
Because it needs the workload itself is using the CPU. Use the CPU there because it's significant metric from your use case. But if you are just pulling a message from wherever and pushing to another third party, the CPU is not your critical metric. The critical metric could be the amount of messages in the queue, the response time, and so on, but not the CPU. The CPU is a side effect. It's not the critical metric from your workload. Probably, if you have an observability and alerting, you won't raise an alert. No, this microservice is consuming too much CPU. Probably you have an alert. The email queue has grown too much. Take a look. Why don't use that metric that is useful for alerting for scaling? That's the point that we said the CPU and memory is good, but it's not enough for a lot of workload.
That's awesome. And how does KEDA then, how does it work? How does KEDA see that workload, or that, how can KEDA connect to, queue or something else?
Mm-hmm. Yeah, KEDA supports basically, this is like the big benefit of KEDA is basically that we have a built-in catalog of external connectors to the external services. So there is like 65 plus different connectors to the services. So basically it's like Kafka, RabbitMQ, Prometheus, AWS, GCP, whatever. And from the user's perspective, because we are trying to make the event-driven autoscaling very simple for the users. So basically you just need to specify, this is my, for example, RabbitMQ queue, the queue name, and the threshold that you are interested in. So I would like to, for example, have 10 messages there in average. So we are trying to keep the number of unprocessed messages there over there. So this is the case. So basically KEDA connects to this service
using their own SDKs.
Yeah. And we don't actually manipulate the data itself, the data that are there. We are just monitoring the metrics about the data. So KEDA itself doesn't manipulate the workload. So this is also important stuff to mention. If you have your existing applications, you can easily plug KEDA in because you don't need to change anything about the application because we are just scaling it out. So we don't need to change anything workload itself.
That's awesome. And if you've got 65 plugins, but if I have something else and that there's no plugin for that,
we got you covered. Yeah.
How can I do that then?
The good response for an open source is open a PR, adding the support. The real response, if your requirement is really close to your use case, or it depends to aggregate different factors in the scaling, KEDA already support two scalers, which are a metrics API for REST server and external metrics for gRCP. That basically you can configure your own server and say to KEDA, do a GET request against this server and parse the response JSON and give to Kubernetes this JSON path using metrics API. Or you can implement the gRPC interface, and when KEDA asks for the value to your own server, you can respond whatever you want. And
that's awesome.
So you can extend KEDA without contributing to KEDA. It's something that we support because there are closed use cases, other use cases using public services, but really close to business cases and not something that we can abstract for an open source project. Or maybe there are third parties that you can just make a GET request and go ahead. There are the options there. And apart from that, we have recently added an option in the middle for using all the built-in scalers as metric sources to build your own custom formula. You could configure and say, okay, I want to scale, for instance, one real use case for this that I have faced with. You have the typical queue and a database, the typical consumer that everybody could have. My queue is growing, so I scale out the consumer. More consumers overload the database. So they respond slowly, the queue grows. In that scenario, scaling out more won't help you. Indeed, it's worse because you are doing a DDoS against your own database. But you could get the metric from, let's say, AWS via CloudWatch Scaler and write your custom formula saying, if the CPU of the database increases, decrease queue.
So you can make an algorithm of more than one source to optimize your workload.
Basically, the first stuff that Jorge mentioned is we call it external scaler. So we have the interface, we implement your own. And the second one is the new addition that we have. So it's useful when you have multiple, because you can define multiple different services targeting the same workload. And the default behavior is that the maximum value is selected. So for example, if you have 2 RabbitMQ queues, so the large number is selected. This is the stuff that it's in Kubernetes, and we rely on Kubernetes on the HPA on that, on the scaling decision. But this is like the limitation. So we introduce the formula stuff. So basically it's a mathematical formula that you can say scalar 1 plus scalar 2 divide whatever, do all the magic you can imagine with those numbers. So it really brings you a lot of complexity and use cases that we can.
It opens possibilities.
The use case that I have explained about the worker, something that I have faced with.
Yeah.
It's like the previous solution was, okay, let's manually scale down the workload because we need to give some time to the database. And now it can't be automatically modified and adjusted on the fly.
Yeah.
If your database is overloaded and your worker is not critical, you will have the alert in your queue, but the database won't fail because maybe that database is used for another.
Oh yeah, and your services. Yeah, it all depends that your service is still running. That's the main thing.
Other like simple use case for this is, it was a query from a user. He was asking, I need my workloads to be over provisioned by 3 pods all the time. No matter like the autoscaling. And this is hard to achieve because, we are autoscaling by the specific number.
Mm-hmm.
With these scaling modifiers, we just wrote a formula because he knows each pod can process 3 messages. I want extra 3 pods. That means like 3 multiplied 3 is 9. So the formula is basically take the metric value plus 9. And that's it. And then it's covered. So he's always over provisioned by 3 pods.
Yeah, if your pod takes a long time to start up, it's something.
Yeah. This is basically the point, because we rely indeed on Kubernetes, and Kubernetes scheduler may take some time. The image might not be on the node, so it's all about scheduling. Actually, autoscaling is scheduling new pods, creating new pods. No magic behind it.
Okay, what is your coolest project which you did?
I don't know. There are quite good projects. Yesterday there was a session about a nice project in a huge company as BlackRock. What's interesting talk from a girl from there. Really good things and really strange things. So,
What is your strangest thing then?
Strangers.
It's a Siri, but
we have done quite strange use cases. It's under NDA.
oh, it's under yeah.
You don't have to call them by name.
Can you use KEDA in every cloud? So AWS and Azure and every Kubernetes cluster, also my kind cluster?
Yes, for sure.
Yes.
The only limitation is related with which APIs does your cluster support. Why? Because there was a change on 1.23 and they deprecated autoscaling V2 as a V2 beta 2. So we had to try to switch to the autoscaling V2, the GA stable version, the GA version. So maybe you need to check which KEDA version is for your Kubernetes version, but in the same way that you will have to do with any other dependency, just for API compatibility.
But KEDA is still relying on the Kubernetes autoscaler?
Yes. Yeah. Basically, the idea also the main idea behind the project was to make it simple for users and also try to not reinvent the wheel. So we rely on Kubernetes internals, basically. So what we do, or KEDA, what does is basically it instructs HPA. It gives you the metrics, basically, because HPA has a interface that you can provide your custom metrics.
Yeah.
And write your own solution, but that's tricky, because you need to do all the stuff. So KEDA is basically connected to this interface and feeds the metrics to HPA. So the scaling part is handled for us, and because HPA cannot scale to 0, it can't do that.
No.
So basically KEDA scaling from 0 to 1 and 1 to 0, and then keeps the rest of the scaling on HPA.
To be 100% accurate, HPA does support scaling to 0.
It's gate, yeah.
Behind a feature gate that you have to enable, which just discard any managed Kubernetes in any cloud.
Yeah.
You cannot change any feature gate. And you need an external scale, an external metric. So you do need any external metric server deployed in your cluster.
So basically, you even if you enable this scale to 0 on HPA, you still need to provide your own metrics.
Yeah.
It won't work with CPU or memory, because if you think about it, it doesn't make sense because the CPU memory metrics are the metrics of the application.
Mhm.
So once you scale the application to 0, you lose the source of the metrics.
Yeah.
So you are screwed, right? So this is the important stuff about scale to 0. But because we or KEDA rely on the custom metrics, external metrics, we can do all the stuff with the application.
Apart from that, there is another important or interesting point with KEDA related with the technology for scaling, because the HPA is not reliable from the point of view of killing the not working pod. If you are processing any long-term job, for instance, you are generating a KPI that needs 30 minutes, and you have a scale object, and you scale based on the HPA. If the source metric decreases, the HPA controller will kill any pod.
Yeah.
Which pod? Who knows? Random. And maybe it kills the pod that is still working, so it's not worth, because your workload will fail. For that, in KEDA, we also support scale jobs. It's another CRD that we support, and instead of just exposing the external metric to the HPA controller, we just create Kubernetes jobs. And the goal is, if you need 5 jobs, you configure almost equally, but once it's working, if you say, I need 3 jobs, KEDA will deploy 3 jobs for you and wait until those 3 jobs, or one of them, finishes in any way, succeed, fail, whatever it finishes, but until the job is running, KEDA won't touch it at all. So if you have any long-term execution, it's the way to go. For instance, for CI, we have 2 scalers, one for Azure DevOps and the other for GitHub runners, for having your agents running in your cluster and your own infrastructure, but on demand. So you can have 0 agents there, and once a development team enqueue a job in the CI system, KEDA will spawn a runner or agent for you as a job in the cluster. So once the job finishes.
Oh, that's awesome. That saves also money and
yeah, it's basically like a cron job on steroids, basically. Because cron job, creates like a jobs periodically by the cron schedules, Kubernetes jobs, but we created the jobs on demand. So if you need the metrics, you see the metrics, just create the jobs. Yeah.
For instance, that's a typical use case that we have in Lidl. It's not a secret. And that is not under NDA. And there are a lot of other companies which are taking advantage of this for saying, okay, instead of having 40 agents already there every day, I will deploy an scale object. I will have 10 preload agents for the quick start, for the starting faster as possible. But if suddenly I have 40 jobs pending in parallel, KEDA will schedule the extra jobs there. So you are saving money if you don't need. So you are indeed autoscaling also your CI working agent.
Bij ACC ICT staat alles in het teken van continuïteit waarborgen voor bedrijfskritische applicaties. Of het nu gaat over Managed OTAP, Cloud en Kubernetes, ze geven hier invulling aan om door samen met hun klanten een toekomstbestendige strategie uit te stippelen voor het gehele proces van ontwikkelen tot en met productie.
Can KEDA only schedule Kubernetes workloads, or can KEDA also schedule nodes?
In theory, it can, but this is not the main focus that we have. So we are focusing on the application level, because if you think about it, basically the application autoscaling makes the pressure on the cluster autoscaler.
Yeah.
So you need more nodes, you need more pods, so you will create more nodes. But there are also discussions that we would like to maybe help the cluster autoscale a bit, because we know the metrics, so we know that something is coming.
Yeah.
So we can be more, more proactive. Unfortunately, the cluster autoscaler, it doesn't have any interface that we can talk to and give it a hint. It's almost like a black box that is doing the magic on the CPU requests and limits in the cluster. But we are exploring these capabilities, definitely. Yeah.
Oh, it should be cool. Because I had a problem with a customer that the cluster autoscaling went too fast up and also too fast down. Yeah. And it went too fast down, and then there were no resources to run the cluster, and then the autoscaler went, oh, there are no resources, I will scale up, and then the workload was already gone, and then I'm scaling down. The customer said, yeah, we have downtime. Why?
Yeah. This is like, especially the scaling down operation is expensive, right? So
Yeah.
We are also thinking about because we can scale the workloads, we can schedule jobs. So we are also thinking about different type of resources. So maybe talking a little bit to the cluster side, or maybe spinning out VMs, or another extra stuff around Kubernetes, not just the Kubernetes stuff, but maybe some additional stuff. So we are also thinking about this, or storage also as well.
Storage is...
A quick note, because maybe someone is hearing us and has the same issue about the downtime during the scaling down. In that case, check if your pod disruption budget is working as expected.
Yeah.
Because because I have seen this issue or this question quite commonly in our communication channels.
Mhm.
And the PDB, the pod disruption budget, is the rule that Kubernetes will respect during the draining node operation. So you can say never drain more than one pod per time during the rebalancing operation between nodes.
Yeah, but if you have it that the KEDA says I'm scaling to 0.
If you scale to 0, nothing to do there with the PDB. Yeah.
Yeah, well, it was a misconfiguration at that customer, but it still should be fun that KEDA also scales my nodes if they see a huge workload coming.
Yeah. But it's hard to achieve because you have these different providers, different clouds, so it's harder to achieve.
Yeah,
Maybe talking to cluster API might be the way for us. So
maybe something for the future.
yeah, this is definitely on our roadmap.
We are not close to explore new ways because our focus is on autoscaling, but the autoscaling also includes cluster autoscaling. So we are open to explore that way just for making the things simple to users. The autoscaling should be simple.
Yeah, but autoscaling is hard, but it's now simple. But still, you have to think about how your application works, and you need to know your application. And that's a problem.
Yeah. Also, it's worth mentioning that you need to be careful when you are introducing autoscaling for certain type of applications. For example, if you have some Java applications, they can start, in minutes. So if you are scaling out or down, you should be careful about, also this kind of stuff. So because it is not about just the scaling, but also about the starting the container, starting the application. So maybe
can we set timers? Like, does KEDA know? Can I tell KEDA that my application takes 5 or 10 seconds to start up?
Do you mean cooldowns during the scaling?
Oh, well, also startup. Can I tell KEDA that my application takes 2 minutes to start up?
No, because KEDA doesn't scale your application. It's the HPA controller. You can, using KEDA manifest, the scale object, you can configure the HPA policies, the advances, the behavior policies, for configuring and tuning the scaling out and scaling in or up and down. I don't remember the name. But yeah, because it's funny. It's funny because the HPA is for scaling out and in, indeed. Up and down is for vertical scale.
Yeah.
This is the common mistake, and one of our friends is very, very particular about this. So
I don't remember. I think that our scale up and scale down policies, you can configure and say, okay, don't scale every 15 seconds because my workload needs 1 minute for being ready. So the scale up cooldown, instead of being 0, will be 100 seconds.
But the other point is also that basically we are monitoring the pods. So the pod is already started, or like it's scheduling, so it's been counted as an active stuff.
Okay.
So you don't need to actually care. It was more from the developer's point of view that they might complain, oh, the autoscaling is slow. The autoscaling is as fast as your application start is,
Yeah.
and the Kubernetes scheduler is. So this is the critical point. So
You just touched vertical autoscaling.
Mhm.
Does KEDA support that?
No. And if you think about it, because vertical autoscaling, as Jorge mentioned, is like scale up and down,
Yeah.
which means that you are extending the
Same pod.
the same pod, yeah. And it's about the resource requests.
Yeah.
And this is usually around CPU and memory. So there are I would say just edge cases when you would like to extend the CPU request based on some different metrics. But we were discussing with this with a couple of people, and I haven't seen a huge demand on that.
Yeah.
Because you are operating on different set of metrics, the CPU memory.
There is another important limitation, and is that the VPA controller didn't support the external metrics API until 3 months ago.
Yeah.
It supported officially 3 months ago the external metrics. So until they include the support, we haven't had anything to do there.
And the other point is that you shouldn't combine both approaches for the same workload.
That's a good tip.
Because it would clash. I think that Google has its own. It's called
Multidimensional. Yeah.
So it's a combination of both. And I know that there are some people in a community trying to also bring this to Kubernetes. So we have the combination of both HPA and VPA in the single. So you can there more fine-tune the rules.
Yeah, but in my opinion, the VPA is old-fashioned because you treat your pod as a pet and not as cattle. You need to.
Yeah, but I think that the recommendation mode for VPA is good because it help you right-size the application.
Yeah, that's good.
And you don't have to use VPA for that. You may use different tools, but I would say the recommendation, because it's hard to set, you are a developer, you're developing an application, and maybe, the DevOps team will ask, how much, resources do you need? And the developer, what does he say? As much as possible, right? So he will provision the stuff.
Yeah, of course, always.
Because it's hard to right-size the pod, so the container. So basically, I think that this point is very valid to right-size the application, because it also can save the costs.
And also for applications. Right now, we live in cloud-native environment, and majority of us think on applications like stateless applications. But that's not actually all the world.
No.
And I say because I have seen not only databases, because maybe you can say, no, of course, if you have a database, no, there are applications or which manage sessions. In those applications, you cannot just scale out. In those scenarios where the state is important, maybe the vertical pod autoscaling makes more sense, because in the database, or if you are managing your internal cache, all obviously taking into account the hot reload, I don't remember the feature. In 1.27, they include as beta the hot change of the resources.
It's called auto mode. So basically, because when you are increasing the resources, you don't need to recreate the pod. So but they include this feature that it will try to it will try to do it on the fly, so not disrupt your application.
In these cases, scaling databases where more instances in parallel won't help you, the vertical autoscaling makes sense totally. But it's also true that how many people manage database in comparison with how many people manage stateless applications. And maybe our point of view is modified by our own experience and how we think that things have to be done. For a stateful application, vertical pod autoscaler works well, in my opinion.
How do you see the future of Kubernetes?
Oh.
I forgot my crystal ball, but if I put a crystal ball on the table, what would you see, or what would you like to see?
I think that is controversial is a good word in English.
Controversial.
Controversial. Oh, yeah?
Be controversial.
No, I think that Kubernetes is in a risky position because nowadays AI is being really strong force pushing technology, and Kubernetes has to be ready for AI or it will be out of the game. If the AI establishes itself as new technology, maybe next year the AI goes down and the barbell has exploded. Who knows? But I think that the life of Kubernetes will depend directly on how the AI grows and if it's ready or not for AI. AI is where is the money right now.
There's where the money is, yeah.
I would generalize this actually. Like Kubernetes is good in what it is doing, but maybe like supporting different kind of workloads, the AI stuff, the models, because it's a huge amount of data and Kubernetes is not suitable for it at the moment. imagine a use case when, for example, you have an application that is working on some model, and you would like to, for example, autoscale the application.
Mhm.
It means that it would probably needs to recreate the model, for every replica or something like that. So more like this kind of different kind of workloads that needs to be supported by Kubernetes in the future. I think this is the stuff that should be focused, not just the status application. This is covered. Stateful applications, okay, and now like this different type of workload. This is my opinion.
Cool.
Okay. Thank you for your opinion. We haven't heard that one yet, so that's a great new insight. With that, I would like to thank you for your time to join us. Well,
Yeah, for the great insights. I've learned a lot.
it was an item on his bucket list in the podcast. So thank you guys for helping him with his list. So and we will follow your development very closely and hope to see you again in the future.
Awesome, thank you.
Okay, thanks.
Thank you very much.
Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k8spodcast.nl via Spotify, Apple, Google Podcast en alle andere favoriete podcastproviders.